Welcome in my channel Digital World. Today in this video we learn about Vlab and how to use Vlab to design and implement digital circuits. So search in Google Vlab IIT Bombay. Then click on first link IIT Bombay. There are multiple labs are there under this virtual laboratory at IIT Bombay. So click on Digital Logic Design Lab. Then click on List of Experiments. Here multiple experiments are there. Today we learn how to design 8-bit digital comparator using MSI ICs. So click on same link. Now read the aim to design and implement 8-bit comparator using IC 74LS85. Click on theory. So this is the theoretical part, that how to compare 8-bit data. So go through the truth table. Here few examples are given. For example, A is equal to 0 and B is equal to 8. It is represented in binary form. So A is 0 and here is B is 8. So it shows that B is greater than A. So the last condition is satisfied, that is A is less than B, this is high, A is equal to B is low, and A is greater than B is low. Similarly, next example is A is 64 and B is equal to 8. So this indicates that A is greater than B, this condition is high, and rest of the two conditions are low. Third example is when A is equal to 96, B is equal to 96. In that case, both A and B both are equal. So this condition is high and rest of two conditions are low. So in this way, we have to learn about how 8-bit comparator work and what are the examples we have to check. Then click on pre-test. Here few basic questions are given. So read the question and tick on correct answer. Then click on procedure. This is the procedure that how to use 8:8-bit digital comparator. So there are few steps. First click on main switch. Then set appropriate input. After giving the input, observe the corresponding outputs and verify the result. There are two inputs, input A and input B. As this is 8-bit comparator, A is of 8-bit and B is of 8-bit. So B is connected to pin number P0 to P7 and A is connected to pin number P8 to P15. Now in case of 8-bit comparator, there are three outputs are there. A greater than B, it is connected to pin number 15. A is equal to B, it is connected to P14, and A less than B, it is connected to P13. Now here is small video is there. Click on this video button and just observe that how to do the simulation. Now see, click on simulation tab. So read what are the inputs are given. So there are total two inputs, A and B. Both inputs are 8-bit. There are three outputs are there and these are connected to respective pins. Here we have to work with 8-bit comparator. So we are using two 4-bit comparator ICs. So first IC 74LS85 and second 4-bit comparator IC 74LS85. Now in this case, there are three outputs, OP3, OP14 and OP15. OP13 is nothing but A less than B. So this is A less than B, this is A equal to B, and this is OP15 is A greater than B. Similarly, here total 16 inputs are there, P0 to P7. This is nothing but input B. Next one is P8 to P15. This is nothing but input A. So there are two different sets are there. Now we have to see the simulation. first click on main switch. So VCC switch is on. Now the first condition we have to check. You can see here IP0 to IP7 is 0 and IP8 to IP15 all are 0. So A is equal to 0, B is equal to 0. Here the condition is satisfied, that is A is equal to B. So pin number 14 is A is equal to B, only that LED is on. Now the second case is we have to give input to B only. So B is connected to IP0 to IP7. So just click on P0, P1, P2, P3, P4, P5, P6, P7. Now here IP0 to IP7 all are 1 and IP8 or input P8 to input P15 all are 0. So this indicates that what condition? This condition is connected to P13. P13 is nothing but what? A less than B. Yes, because B all pins are 1 and A all pins are 0. This shows that A is less than B. Now check the second condition. You have to make all bits 1. So IP8 1, 9 1, P10 1, P11 is 1, P12 is 1, P13 1, P14 1 and P15 1. So here all inputs are 1. So A is equal to all ones, B is equal to all ones are there. So this condition is nothing but A is equal to B and P14 is nothing but A is equal to B. This condition is satisfied. Now check the third condition. We can make P0, P1, P2, P3, P4, P5, P6 and P7. All bits are 0 but inputs are given to P8 to P15. So in this case we can see here P8 to P15 all inputs are 1 and P0 to P7 all inputs are 0. So this indicates that A is greater than 1 B. So OP15 this LED is on and this is nothing but what? A greater than B. This condition is satisfied. So this is the easy method that we have to check that different conditions for 8-bit comparator. So when all bits are 0 and all bits are 1, then A is equal to B condition is satisfied. When A is equal to 1 1 1 and B is equal to 0, then A is greater than B. When B is equal to 1 1 1 and A is equal to 0, then A less than B. So in this way just check the simulation of 8-bit comparator. Now click on post test. There are few questions are there as per the observations. Read the questions and take the correct answers. Then click on references. There are few references are given over here through which we can read more about comparator. And last but not the least, click on feedback, right, and give the feedback to the virtual lab. So this is the way that we can use virtual platform to design and simulate different types of digital circuits. Thank you so much.